All right, this video is going to cover a little bit more of the logic behind some of this stuff we're going to implement, namely being forward checking. So if we see here on the Sudoku board, we have an impossible and unsolvable scenario. Within the confounds of Sudoku, this board will never be able to be solved as nothing can go here. A 4 has been placed here when it should have gone here, and therefore this board cannot be solved and will lead to just an array of wrong, incorrect selections potentially. So we're gonna take that idea, and a solution you can now do is to backtrack and to remove this and try again. But we want to avoid backtracking as much as possible. We want to make sure that before having placed this 4, that we made sure that it was actually the most optimal or correct square. And this is it once again within the confines of Sudoku. Now for a algorithm that we're working on, if we were to have something that's generated like this already, and it's continuing forward. Now, understand this, we're going to say this tile right here has not actually been generated while it is empty, and it would get chosen to be an empty tile. We're going to say it hasn't actually collapsed within the algorithm. So right now it's just some potential options for what can exist here. We see here, let's say the actual tile that's going to collapse next will be this tile. Now, that's not necessarily the correct tile that would really get picked in the algorithm, but we're going to use this as an example to show how things will break. Under this tile, we know that there can exist a few options. This can exist there, as well as this. Based off of my tile rule sets, those are the two tiles. Now, if we were to say collapse this tile, we see that there's an issue here. Nothing can exist here or here that will complete this map. It has created an unsolvable scenario, and it will break and loop an infinite loop and cause all sorts of issues. So we need to stop that. Because now what we would have to do is backtrack. We would have to get rid of this and probably get rid of this and then try again. And if we have weird seeding issues, we could just continue looping back and ending up in the same place. So we want to stop that from happening. So what if instead of collapsing that cell entirely, what if we just we had it selected, we know its position, and now we're going to check these two uncollapsed cells, and we're going to look at what they can exist as right now. Because this has been collapsed, there's only certain things that can exist here and exist here based off of our rule sets. And so we can reference what can exist here and what can exist here when determining what we want to pick here. If we look here and then we check these first, we'll see, oh, look, nothing can exist here. Like there are no options that match with this rule set. And so instead of collapsing it, we would then iterate to the next option, which would be this. And I'm just placing this here so I can go off here. Then, without fully collapsing this, we'll check, okay, can this exist here? And can it exist because of these two tiles? Can these rules allow for this tile, and can these rules allow for this tile? And yes, they can. And this tile can exist next to empty blank tiles, and it can exist above this space because that can go right there. And then furthermore, that can exist right here. And perfect, we now have a solved map. Whereas previously, we were picking the wrong option up here, and that was causing all sorts of backtracking loops and potential breaks. And now, using forward checking, we've already solved it. And that could happen right here too. All right, so there's actually two tiles that can exist under here. It's this and this. So what if again we had picked that, and now we're at another impossible and in an unsolvable scenario, so we'd have to backtrack and keep trying, keep trying. So we want to forward check. We want to make sure that this can definitely exist here before placing it. And we know that that can definitely exist there. this absolutely can't exist there, and it is the only option. There's only one tile in my own tile set that could exist in this situation, so you wouldn't have to do a lot of computation. It would just be this one tile. That would just be it. So we can save a little compute in those situations. And that is going to be what we start to implement, is doing that forward tracking. And then when we get a guarantee for something that can exist, like this tile, then we're going to update, we're going to collapse it, and then we're going to update the neighbors further. And that will be what the next video is starting to cover. So this is all part of this idea of collapsing a cell and then updating its neighbors, but making sure that they can, that whatever we're going to pick next after we update it can continue to exist there, and it works for the first cell. If we want to place something right here, we need to make sure that it can exist here. If there's nothing here, then that's good and great. It definitely can. But we always will need to do this forward checking, making sure that we can always place something before we actually place it to stop those unsolvable scenarios. So I hope that makes sense, that we will now start to actually implement it. So that will be the next video.